Hi, my name is Matt Maxwell, and I'm a product manager for Tektronix Spectrum Analyzers. And this is a quick how-to video for testing Bluetooth RF physical layer parameters using the RSA 607A. It's a Tektronix real-time spectrum analyzer, which is controlled through USB to a PC running SignalView PC software. Now there's two basic kinds of Bluetooth parametric testing for physical layer. Either you're doing parametric testing of a module, which would mean research and development, automatic testing for design validation where parameters are checked. And in both of those cases, you're looking at a series of measurements that are basically called for out of the Bluetooth standard or the Bluetooth SIG. Another category of testing would be testing for Bluetooth troubleshooting to make sure a device using the module is connected correctly and working correctly, and the software is working as you intend it to. So let's get started. Here I have an RSA 607A connected to SignalView PC software. It's a USB spectrum analyzer, good mid-range performance. And I've tuned already to the frequency where the Bluetooth is. So I've got the frequency, the reference level, the span, and the RBW all here, the main four controls of a spectrum analyzer. So I'm going to show a few other displays here to show off the modulation quality. I'm going to bring in the real-time display, the spectrogram. So the way SignalView PC is oriented is there's displays in different folders of measurements. And then I'll go down to the Bluetooth measurements here and bring in the constellation diagram and maybe an eye diagram. There's also a Bluetooth summary for all the modulation quality, but it takes a second to draw here. Basically, I don't have modes as much in the RSA with SignalView PC. I just have to bring in as many displays as I have space on the screen to show. And so the problem at the moment is I don't have a complete burst that I'm capturing, and I know that from the error message on the constellation diagram shown here and the time overview. Now I'm going to close some of these displays once I get this set up, but now I get to where I'm capturing a complete burst, and maybe just to further refine this here, I do have the clean constellation diagram at the moment. I'm going to change the level of and turn on a power trigger so I have consistently capturing Bluetooth signals here. The spectrogram shows me the signal history over time, looking at the power versus the frequency, the frequency versus time, and the power is indicated by the color. I've got a crowded display here, so that might be too much. But kind of the two ways I could qualitatively look at the modulation quality would be with the eye diagram, or quantitatively look at the frequency error on the constellation diagram, trying to get some sense of the modulation quality. This might be interesting, for example, if you have a new antenna design and you want to make sure you've improved the performance as a result of the antenna. This would also be helpful to make sure if you've made changes to the software that you haven't messed something up in terms of the physical layer transferring of the data. So make sure the constellation diagram is still clean. And I can see pretty clearly the time domain part of the signal, the RF envelope, like a zero span display, and the time overview, and also can run the DPX spectrum concurrently as well. So that's basic measurements. Another thing that's worth noting is that if I want to perform programmatic measurements, if I want to automate these measurements, all these controls are available via programmatic interface through the SignalView PC PI with a full programming manual that's also available. Hopefully this is helpful just to show you how to make some very basic measurements, to do the modulation quantitative and quantitative measurements with the constellation diagram here in the upper right and the eye diagram in the lower left. So hopefully this gives you a little better understanding of how you would test Bluetooth parameters for the physical layer using the RSA 607A real-time spectrum analyzer with the SignalView PC software. I thank you for your time.